We're going to start off with this idea called mutagenic effects. What does the word mutagenic tell you? X-Men? Could be. Yeah, unfortunately, all the mutations are bad, right? Mutation causing, right? Or mutations are caused. Mutagenic means mutations are being created, right? So mutagenic effects from gamete exposure, gonadal exposure, prior to fertilization. We say things like they are not yet well understood. We know these mutagenic effects happen, but they're stochastic, random, which makes them harder to figure out. You know, if we know a threshold for something, it's easier to study it and figure more out about it. Without thresholds, stochastic effects are more difficult to discuss, right? As well as it's difficult to study cells after radiation exposure. I mean, for example, you can only see visible chromosome abnormalities during metaphase, right? During just the tiniest part of mitosis, right? Okay. But some conclusions from prior studies, conclusions from insect and mice studies. These are studies are done on primarily fruit flies as the insect, and they're easy to experiment with. They have short lifetimes, short gestational periods, and it's easy to see like this fly grew a weird wing or something like that, right? So it's easy to experiment with flies, as well as mice, rats, things like that. Easy to experiment with them. Again, short gestational periods, small animals, easy to work with, but that's how they figure these things out. So insect and mice studies primarily. We say things like about mutagenic effects, such as the dose-response curve is definitely linear, non-threshold, meaning no safe dose. Any dose above 0 puts you at risk for the effect you want to talk about. And the occurrence of the effect goes up proportionally with dose. You double the dose, it's twice as likely for you to develop the effect. Right? If there's a 10% likelihood at 10 milligray, then there's a 20% likelihood of the effect at 20 milligray. Right? The effect goes proportional with the dose. The effects are stochastic, increasing in frequency or increasing in probability or likelihood, but we never say things like the effect is going to happen. Right? We say it's stochastic or random. Increasing in frequency, but not in severity. Another way to think about stochastic effects is they are all or none phenomenon. You either do or do not develop the effect, and it's random, right? You expose 10 people to, small amount of radiation. None of them could develop cancer. All of them could develop cancer. 2 of them could, right? So it's random, right? Just increases in likelihood. Frustrating.